On July 1, 2025, astronomers discovered something extraordinary racing through our solar system. A massive interstellar object designated 3I/Atlas that dwarfs all previous visitors from beyond our cosmic neighborhood. This colossal traveler, potentially up to 12 kilometers wide, is moving at over 150,000 miles per hour on a trajectory that confirms its origin from another star system. Unlike the mysterious Oumuamua or the smaller comet Borisov, 3I/Atlas represents our largest confirmed interstellar visitor, offering unprecedented opportunities to study material from distant worlds before it vanishes forever into the cosmic void. The historic discovery. What started as a routine night of sky surveillance on July 1, 2025, became one of the most significant astronomical discoveries of the decade. The Atlas Survey Telescope in Rio Hurtado, Chile, operated by the University of Hawaii as part of NASA's Planetary Defense Network, detected an unusual moving object approximately 670 million kilometers from the Sun. Initially catalogued as A11PI3Z, this faint dot immediately caught astronomers' attention due to its peculiar trajectory and unexpected brightness. The Asteroid Terrestrial Impact Last Alert System, known as ATLAS, consists of 4 telescopes strategically positioned across the globe. 2 in Hawaii, 1 in Chile, and 1 in South Africa. These automated sentinels continuously scan the night sky, photographing the same regions multiple times to detect moving objects that might pose threats to Earth. However, what they discovered on that July night was something far more extraordinary than a potentially hazardous asteroid. Confirming interstellar origins. The confirmation that 3I/Atlas originated from beyond our solar system required careful analysis of its orbital mechanics and trajectory. Unlike objects native to our cosmic neighborhood, which follow predictable elliptical paths around the Sun, interstellar objects travel on hyperbolic trajectories, essentially one-way tickets through our solar system. Dr. Paul Chodas, director of NASA's Center for Near-Earth Object Studies at the Jet Propulsion Laboratory, explained that the object's velocity and trajectory definitively prove its interstellar nature. When astronomers traced its path backward through space, they found it approaching from the general direction of the galactic center, though pinpointing its exact stellar origin remains impossible due to the vast distances and timescales involved. The object's designation as 3I/Atlas reflects its historic significance. The 3I indicates it's the third confirmed interstellar object ever discovered, following 1I/Oumuamua in 2017 and 2I/Borisov in 2019. The Atlas portion honors the survey system that first detected it, while its formal comet designation C/2025N1 indicates it was the first non-periodic comet discovered in the first half of July 2025. What makes this discovery particularly remarkable is the object's speed relative to the Sun, approximately 60 kilometers per second or about 134,000 miles per hour. This velocity is far too high for any object gravitationally bound to our solar system, providing conclusive evidence of its interstellar journey. Unprecedented size and characteristics. The sheer scale of 3I/Atlas sets it apart from all previous interstellar visitors. Current estimates suggest the object measures between 5 and 15 kilometers in diameter, making it potentially dozens of times larger than Oumuamua, which was only about 400 meters long. If confirmed at the upper end of these estimates, 3I/Atlas would be the largest interstellar object ever observed. Dr. Daryl Seligman, an astrophysicist at Michigan State University, who has been studying the object since its discovery, describes 3I/Atlas as shockingly bright despite its enormous distance from Earth. This brightness could indicate either exceptional size or an unusually reflective surface composition. The object's luminosity allows telescopes to observe it clearly even though it remains much farther from Earth than Oumuamua was when discovered. Early spectroscopic observations reveal that 3I/Atlas exhibits a reddish hue, similar to objects in the outer regions of our solar system. This coloration suggests the presence of organic compounds and complex hydrocarbons that have been altered by billions of years of cosmic radiation exposure. Perhaps most intriguingly, 3I/Atlas shows clear signs of cometary activity, including a faint coma, a hazy envelope of gas and dust surrounding the nucleus. This activity indicates the presence of volatile materials like water ice, carbon dioxide, and other compounds that sublimate when heated by solar radiation. Comparing the interstellar visitors. The discovery of 3I Atlas gives astronomers their third data point for understanding interstellar objects, and honestly, it reveals some fascinating diversity among these cosmic wanderers. Each visitor has exhibited unique characteristics that, well, really challenge our expectations about objects from beyond our solar system. Oumuamua, discovered back in October of 2017, is still the most enigmatic of the three. Its extremely elongated shape, lack of visible cometary activity, and that mysterious non-gravitational acceleration, these all sparked intense debate about what it really is. Comet 2Y Borisov, discovered in August 2019 by amateur astronomer Gennady Borisov, turned out to be more conventional in its behavior. This object clearly showed typical cometary characteristics, including a visible tail and a composition similar to comets in our own outer solar system. 3I Atlas, though, seems to bridge the gap between its predecessors while introducing a whole new set of mysteries. Like Borisov, it shows cometary activity, but its enormous size and those unusual brightness patterns definitely set it apart. Dr. Mark Norris from the University of Central Lancashire notes that 3I Atlas doesn't look like either of them, which is crazy and exciting. The rapid succession of these discoveries, 3 interstellar objects in less than a decade after centuries of seeing none, suggests, such visitors may be far more common than we ever thought. Advanced Observational Campaign. The astronomical community has really mobilized an unprecedented international effort to study 3Y Atlas before it disappears into the depths of space. Unlike Oumuamua, which was discovered as it was already leaving the solar system, 3I Atlas was detected early enough to allow extended observation campaigns using the world's most powerful telescopes. The James Webb Space Telescope, with its exceptional infrared sensitivity and massive 6.5-meter mirror, is perfectly positioned to analyze the object's composition and thermal properties. Webb's instruments can detect specific molecular signatures in the comet's coma and tail, potentially revealing the presence of water vapor, carbon monoxide, methane, and other volatiles that could provide clues about its origin. The Hubble Space Telescope continues to monitor 3I Atlas using its ultraviolet and visible light capabilities, complementing Webb's infrared observations. Together, these space-based observatories provide a comprehensive view across multiple wavelengths of light, revealing details impossible to obtain from ground-based telescopes alone. Ground-based observatories worldwide have also joined the effort. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, and numerous other facilities are tracking the object's brightness variations, rotation, and spectroscopic properties. Radio telescopes, including the Very Large Array in New Mexico, are monitoring for any unusual emissions that might indicate unexpected activity or composition. This coordinated global effort, honestly, represents the most comprehensive study of an interstellar object ever attempted, taking advantage of technological capabilities that just weren't available during previous encounters. Ancient origins and cosmic age. Recent research suggests that 3I Atlas may be one of the oldest objects ever observed, potentially predating our solar system by billions of years. Dr. Jesse Hopkins and his colleagues at the University of Oxford have developed models indicating that this interstellar visitor likely formed around an ancient metal-poor star in the galaxy's thick disk, a population of stars that formed when the Milky Way was much younger. Professor Chris Lintott, co-author of the Oxford study and presenter of BBC's The Sky at Night, explains that there's approximately a 2/3 chance this comet is older than our 4.6 billion-year-old solar system. If confirmed, 3I Atlas would represent a pristine sample of materials from the early galaxy, preserved in the deep freeze of interstellar space for eons. The object's ancient origins could explain its unusual characteristics. Unlike comets in our solar system, which have been repeatedly heated during passages near the Sun, 3I Atlas may be experiencing its first encounter with stellar radiation in billions of years. This pristine nature could account for its unexpected brightness and activity patterns. Dr. Michelle Bannister from the University of Canterbury notes that the gases released as 3I Atlas is heated by the Sun will test theoretical models about ancient comet composition. This temporal perspective transforms 3I Atlas from merely an interstellar visitor into a potential time capsule from the galaxy's youth. Trajectory and future encounters. So, 3I/Atlas is currently following a precisely calculated path through our solar system that will bring it to perihelion, its closest approach to the Sun, around October 30th, 2025. At this point it will be approximately 206 million kilometers from the Sun, just inside Mars's orbit, but still at a safe distance that poses no threat to Earth. The object's trajectory offers both opportunities and challenges for observation. During its closest solar approach, 3I/Atlas will be positioned on the opposite side of the Sun from Earth, limiting direct observation during its most active period. Dr. Astor Taylor, a graduate student in astrophysics at the University of Michigan, explains that despite the object's incredible speed, astronomers will have several months to study it. The comet will remain visible to large telescopes until early 2026, after which it will fade into the darkness of space, never to return. On October 3, 2025, 3I/Atlas will make its closest approach to Mars, providing an opportunity to measure how planetary gravity might subtly alter its trajectory. The object's outbound journey will take it beyond Jupiter's orbit by mid-2026, beyond Saturn by 2027, and eventually beyond the influence of our solar system entirely, resuming its eternal voyage through the galaxy. Scientific implications and astrobiology. The discovery and study of 3I/Atlas carries, honestly, some pretty profound implications for our understanding of planetary system formation, the distribution of organic materials throughout the galaxy, and potentially the origins of life itself. As the largest confirmed interstellar object, it offers an unprecedented opportunity to analyze material from another stellar system in detail. If spectroscopic analysis reveals complex organic compounds within 3I/Atlas, it would support theories that interstellar objects serve as vehicles for distributing the building blocks of life across the galaxy. This concept, known as panspermia, suggests that life's ingredients, or even life itself, might travel between star systems aboard comets and asteroids. The object's ancient age adds another dimension to its astrobiological significance. Materials preserved in 3I/Atlas for billions of years could contain information about the early galactic environment when the first generation of planets was forming. Dr. Rosemary Dorsey from the University of Helsinki emphasizes that studying 3I/Atlas provides insights into the role that ancient interstellar comets play in seeding star and planet formation across the galaxy. The object's composition and behavior could reveal whether the chemical ingredients necessary for life are common throughout the cosmos. The discovery also informs models of planetary system evolution, suggesting that the ejection of material into interstellar space is a common process that connects distant stellar systems through the exchange of matter and potentially biological information. Future detection and exploration. The discovery of 3I/Atlas comes at a pivotal moment in astronomy, as new survey telescopes prepare to, really revolutionize our ability to detect interstellar objects. The Vera C. Rubin Observatory, scheduled to begin operations soon, will photograph the entire visible sky every few nights, creating a comprehensive movie of the cosmos that should dramatically increase the rate of interstellar object discoveries. Predictions suggest that Rubin Observatory might detect between 5 and 50 interstellar objects during its 10-year survey, with some potentially as large as 3I/Atlas. The discovery also highlights the potential for rapid response missions to intercept future interstellar objects. While 3I/Atlas was detected too late for any spacecraft to reach it, several space agencies are developing concepts for high-speed interceptor missions that could be launched on short notice when the next visitor is discovered. The European Space Agency has proposed the Comet Interceptor mission, designed to study a pristine comet or potentially an interstellar object. NASA and other agencies are exploring similar concepts that could provide direct sampling and analysis capabilities, opening entirely new frontiers in space exploration. These future missions could answer fundamental questions about interstellar objects that remote observation cannot address, including their internal structure, precise composition, and the processes that ejected them from their home systems billions of years ago. A new era of cosmic discovery. The arrival of 3I/Atlas represents more than just another astronomical discovery. It marks humanity's entry into a new era of cosmic exploration where we can study material from distant star systems within our own solar system. Each interstellar visitor provides a unique window into the processes shaping planetary systems throughout the galaxy. As 3I/Atlas continues its journey through our cosmic neighborhood, it carries with it secrets from an ancient star system that may have died billions of years ago. The data collected during its brief visit will be analyzed for years to come, potentially reshaping our understanding of planetary formation, the distribution of life's ingredients, and our place in the galactic community. The rapid succession of interstellar discoveries, from Oumuamua to Borisov to 3Y Atlas, suggests that our solar system exists within a busy galactic highway where objects regularly travel between star systems. This realization transforms our perspective from viewing our solar system as an isolated island to understanding it as part of a vast, interconnected cosmic ecosystem. Future generations of astronomers will have access to increasingly sophisticated tools for detecting and studying these cosmic messengers. Each new discovery will add to our growing understanding of how matter, and potentially life itself, spreads throughout the galaxy. 3I Atlas may be just the beginning of a new chapter in human exploration of the cosmos, one where the universe comes to us in the form of ancient travelers from distant stars. The discovery of 3I Atlas opens an unprecedented window into the ancient cosmos, offering humanity its first detailed look at a massive object from another star system. As this colossal interstellar visitor races through our solar system, it carries secrets from a distant world that may have existed billions of years before Earth formed. The data collected during its brief passage will enhance our understanding of planetary formation, the distribution of life's building blocks, and our cosmic heritage. What other ancient messengers await discovery in the depths of space? Share your thoughts below, hit that like button, and subscribe to Future Facts for more incredible cosmic discoveries. Until next time, keep looking up.